Another minor topic which we touched on a little bit in earlier videos but never quite formalized was this idea of cofunctions. Okay, now sine and cosine, secant and cosecant, and tangent and cotangent, those pairs of functions are what are called cofunctions, right? They're known as cofunctions because if you evaluate one of those functions at a particular angle, the result is the same as when the cofunction is evaluated at the complement of the angle. And really what it comes from is the fact that when you have a right triangle, if we just draw a quick right triangle here, when you have a right triangle, right, the side that's opposite one of the angles becomes the side that's adjacent the other angle, right? So if you think about angle A, right, side A is opposite angle A, but side A is going to be adjacent angle B. And then the reverse happens with side B, right? With side B, I'm sorry, angle B. Side B is opposite angle B. However, it's adjacent angle A, right? So what ends up happening is the sine of A is really the same as the cosine of B. The cosine of A is the same as the sine of B, right? And then the tangent of A is the same as the cotangent of B. The tangent of B is the same as the cotangent of A, right? And again, it comes from the fact that the opposite and the adjacent switch when you switch angles from A to B, okay? And the other thing to note here is that since cosecant is the reciprocal of sine and secant is the reciprocal of cosine, secant and cosecant are also cofunctions, right? So the fact that the sine of A is equal to the cosine of B really means that the cosecant of A is the same as the secant of B. And the fact that the cosine of A is equal to the sine of B means that the secant of A is the same as the cosecant of B. Right? So really those are the 6 relationships that you get out of this. And in terms of actual, like, questions that you could be given here, is the way they would phrase things is something like, alright, if I have the sine of 35 degrees, express this in terms of its cofunction. So the sine of 35 degrees would be the same as the cosine of 55 degrees, right? Because again, 35 and 55 are complements. So the sine of one angle is the same as the cosine of its complement. If they asked you, alright, well, what is the tangent of 15 degrees equal to, right? The tangent of 15 degrees would be equal to the cotangent of 75 degrees, right? And another one might be the secant of pi over 3 is the same as what angle? Well, it's got to be the cosecant, and the only thing that might be a little tricky for you here is it's in terms of radians. So what angle is the complement of pi over 3 in radians? Well, again, to go back to the degree examples for a second. How did I get 55 from 35? I just subtracted 35 from 90 and got 55, right? How did I get 75 from 15? I subtracted 15 from 90. So I'm going to do the same kind of thing here, and I'm going to subtract pi over 3 from 90 degrees in radians, and 90 degrees in radians is pi over 2. So what you're really doing here is pi over 2 minus pi over 3. So you need to get a common denominator, which would be 6. So you'd have 3 pi over 6 minus 2 pi over 6, which is really just pi over 6, right? So the secant of pi over 3 is the same as the cosecant of pi over 6, right? So those are specific applications of cofunctions, right? It's pretty simple. As long as you remember that sine and cosine go together as cofunctions, tangent and cotangent go together, and secant and cosecant go together. It's just a matter of subtracting from either 90 if it's in degrees or pi over 2 if it's in radians to come up with the other angle, right? And again, it really just comes down to the fact that the opposite and the adjacent switch, right? When you go from one angle of the right triangle to the other angle of the right triangle. So it's pretty straightforward, all right? And just one other quick note here: if you're trying to evaluate on a calculator cosecant, secant, and cotangent, what you do is not use these little buttons that say sine -1, cosine -1, and tangent -1. Those are actually not reciprocal functions. Those are inverse functions, and we don't deal with inverse functions in this particular class, so we're not using those buttons. If we want to evaluate secant, cosecant, and cotangent, we have to just do 1 divided by the original trig function, right? So in other words, if you want to evaluate like the secant of 25 degrees, you would enter that in as 1 divided by the cosine of 25 degrees, right? If you want to do the cotangent of pi over 5, you would really do 1 divided by the tangent of pi over 5, right? If you wanted to do the cosecant of pi over 8, you would do 1 over the sine of pi over 8, right? And of course, I mean, you can come up with these approximations if you wish. You can just pretty much go in and say, all right, well, first I'm in degree mode, so let's go to degree mode. If I want the secant of 25, I'm doing 1 divided by the cosine of 25. So that's going to be 1.103. If I want the cotangent of pi over 5, I go back to radian mode. And I do 1 divided by the tangent of pi over 5, which will give me 1.376. And if I want the cosecant of pi over 8, I would do 1 divided by the sine of pi over 8, and 2.613. Alright? So bottom line is, when you want the reciprocal functions, you enter them as 1 divided by its reciprocal. Right? You don't use those sine to the -1, cosine to the -1, tangent to the -1. Right? You'll deal with those inverse trig functions in pre-calculus, right? Not to be confused with the reciprocal functions, which we're dealing with here. Right? Here we're dealing with secant, cotangent, and cosecant, which are the reciprocal functions.